guys, me again. Today we have a Yamaha uh, sound stereo surround sound system that came in for some repair. I already had a look at the unit and I kind of skipped over a lot of stuff because it's pretty much the same as the other Yamaha that I had already in the shop before. Um, you can look at the other videos. It's called Yamahahaha failed the DSP whatever chip repair attempt. So basically, the problem with that one was the DSP chip was internally was bad because I applied a bit of heat on the chip itself and the unit started working again. So and that wasn't a BGA variant, that was a TQFP variant. So the pins were exposed on the outside, and solder was I observed that it was okay. So the chip itself had to be replaced. Customer ended up not wanting to do it, so I said, okay, fine, whatever. This customer, on the other hand, he's willing to fork out the money to get it repaired. So I have, like I said already before, I already had a quick look at the unit, and since I knew from the other unit, it's more than likely going to be a problem on this guy over here in this case. So this is actually part of the HDMI board. So the HDMI board is on this Yamaha. There's all the ports occupied, so it has like 7 or 8 ports on that board. So that whole board is being occupied, and then there's on top of that board there's this guy. This is, I guess, network communications whatever board. But again, using the same technique I did on the other unit, I went around and I put some heat on some parts and to see what made things change or not. So, and it was on this board that stuff started to behave normally again. And I'm pretty certain this guy needs to be reflowed, if anything. And if you look carefully, you're gonna notice it is a Texas Instruments Cinema DSP chip. Yay! So we have another whatever stupid DSP problem. So, but at the same time, this probably more than likely needs a reflow. And the good news is this is a BGA variant, and you can probably see the balls from here. If my camera focuses, you probably see the balls on the side. Yeah, you probably can see it from here. I'm sorry, because I'm trying to do the best I can with my one hand here. If you look at the corner, right there, you see all the balls. Yeah, right there. You see all the balls right under here. So more than likely, this probably needs a reflow. So we're gonna get to that. But on top of that, we have bad caps. So these are these SMD aluminum electrolytic capacitors, and if you notice, there's some that are marked red and the others are not marked red, and that's because these ones test bad. So I went around, and after playing around and checking that this is probably also a problem, I went ahead and I checked the caps over here because I know sometimes they go bad. So just to show you, I have my ESR meter here with me, and I'm going to try to do the best that I can with my recording abilities, because unfortunately I don't have a tripod. Just take a look at one of the measurements I take off this this board. So I have my probes here. Probe negative, negative, positive, positive. 75.2, 75 ohms. And this is a 10 microfarad electrolyte, a surface mount electrolytic. I would say that's bad. Comparison, another 10 microfarad on the board. Same voltage rating at 6.3 volts. About 0.02 ohms. I would say that's good. So we have a lot of that going on over here. Maybe, I don't know if you could have saw that, but sorry if you couldn't see that because I had my phone kind of held weirdly. But basically, yeah, these are all testing bad. And the rest are testing good. So I'm going to have to replace, there's 1, 2, 3, 6 capacitors I'm going to have to replace. And we're going to probably do the reflow on this Texas Instruments DSP anyhow. So yeah, that's it. So I'm going to go ahead, start by ripping out these caps, changing them, and going for the reflow. Alright, so I'll keep you guys updated and I'll show you how I progress. as you can see, this is the work that we've done. So all these caps were replaced. They're the same values, just they're not the same. They're not the SMD variants. They're through-hole variants, but they will work exactly the same way. So, and the rest tests good. So we're not gonna have to change anything else. At least on this board, I'm gonna before I do the reflow process on that chip, I'm gonna see if maybe the only thing it needs is just these caps to be changed. So I'm gonna bring the unit back on this table. We're gonna put it on the table. We're gonna plug it in, and we're gonna see if it works by some miracle. If it doesn't, then we're gonna go ahead with the reflow process, because I know it's gonna probably be that chip more than likely. And we'll see what that takes us. So let me go bring the unit back up on this table, and we're going to see what happens when we fire it up. Show you guys what's going on. So here's the Yamaha on the table, and there's the board back in. And as I suspected, unfortunately, it did not solve everything. So if I go ahead, now it's going to work. I'll show you why. So it's turning on, and the light should come on over here in a second. There you go. So before what was happening, I should have filmed it, but, you know, stupid me, of course, I didn't film it. But basically, I plugged this in right away, everything connected, and this wasn't coming on, so I fired up the hot air gun and applied some heat right over the corner where the DSP chip is, which is about here, but on this side, obviously, because I can't get to the other side, unfortunately. So I applied a bit of heat there, and lo and behold, it clicked on. So it's going to need a reflow. I'm going to go ahead. I'm going to take it out. I'm going to go in my garage because I have a new machine that has not been seen before on video, and you guys are going to see it. And you're going to be pretty intrigued by it and amused. So I'm going to go ahead, take it out, and for those who already have done this kind of repair and, you know, dealing with this kind of stuff, you're going to probably already know what I'm about to do. So we're going to go ahead and, well, actually I already said, so I'm doing a reflow, but there's a special tool that I have that for some people they know and some other people they don't know. So I'm going to go ahead and take it out, bring it downstairs, do the reflow, and you're going to see how amazing it is when you have the right tools for the job. And I just noticed, oh, there you go. You saw that on camera? Went in and went out. Now it might come back, or it might stay like this. I don't know. So we're going to go ahead, give it a reflow. And hopefully that should solve our problem with this unit, and we can give it back to the customer, and hopefully he'll be happy with it. So yeah, let's do that. Right, and we are in my garage, and pardon me for the background noise. That's my vacuum cleaner running. That somebody else in the house is using the vacuum cleaner to clean up some messes upstairs. So, but we're in the garage right now because I have my reflow machine here. So this is my rework / reflow machine. I got this not too long ago, actually, and I got a really good deal on it, so that's why I have it here. And we're going to set this thing up so that we can reflow that chip right there. So that's that stupid Texas Instruments IC right there. And I'm going to be using some MG Chemicals no clean flux paste. This actually works really well. So we're going to apply some of this, and it should reflow that pretty darn good. And we're going to have to cover everything to make sure nothing else gets damaged potentially. So, because basically the way this machine works is we have a top element, which is this thing right here. There's an element right under here. And then we have the bottom element, which is those heaters, as you see. So we have a preheat, there's a bunch of stuff going on. And this is just the right tool you need for this kind of work. So I'm gonna double check some of the settings over here just to make sure that this is gonna work exactly like I wanted to. So basically, this is the bottom of the board. This is the control for the bottom elements over here. So right now we have two values. We have the current temperature reading and the set or desired temperature input. So right now there's a little probe right down there. If you look right down there, that's the temperature probe for the bottom elements. So it's currently reading 22 degrees, which is about right. That's room temperature, more or less. And this is what I have it set to. So the bottom of the board will be heated to about 160 degrees or so. So yeah. And then what I'm going to do is over here, this is for the top thing over there. So you actually can see the element right under there. I'm going to make sure that this is set accordingly. So It's a little bit interesting how this machine works. Basically, we have a bunch of programs programmed into this machine for different types of rework. So for leaded, for lead free, and so on and so forth. So right now I have it at the lead free rework or program mode, because I believe this is a lead free board. So again, current reading, which is actually this guy right there, that's my probe that I'm gonna have to manipulate with. 20 degrees. This is the set value for the current stage, as they call it, so, or step here they call it. So yeah, you're gonna see it running in a couple minutes. I guess I'm just gonna set it up and make sure that everything is where it should be. I'm gonna put some Kapton tape to make sure that nothing flies away during the reflow process, and hopefully that should fix this customer's issue with this board. Yeah, so we're gonna go ahead and reflow it and do all nice work to it. And this is actually my computer. For those who are curious, this is the program that came with this machine, and basically it's, you can control it, you can start, you can stop it, and you have a graph and everything. So it's very nice to have. It's just the RS-232 cable, serial cable, and then I just have an adapter because I don't have a serial port, unfortunately, on this machine. And then this machine, also the other reason that it's down here is because it needs a 240 volt service, so, or supply I should say. So if you look behind, this is the power lead over here. This is the power cord, and it goes into this weird looking plug. This is a NEMA 6-15. So this is basically a 15 amp 240 volt plug, and then next to it I have my normal 120 volt 20 amp receptacle actually. So these two boxes, I basically wired this up, so I have Romex wire that goes all the way to the floor, goes all the way down, and into this doohickey-majiggy. And then inside I have a big cable that goes to my stove plug, which is right over there. So because this is the only plug I know that I have that I can basically pull this amount of power out of, so that's why it's like this for the time being. So again, yeah, 15 amps and just a 20 amp 120 receptacle. So my room doesn't have a plug like this that I can run this wire, so that's why it's down here. So yeah, we're gonna set it up and get it running, and when it's running, I'm gonna show you guys how we progress. I'll just show you what I prepped up here. So this is just the Kapton tape covering all the critical stuff, and then this is the chip that we want to reflow. So there's a bit of some of the gooey stuff, as you can see. That's just the flux around it, and we're gonna go ahead and put it on the machine, and we're gonna start the program, and we're gonna watch it reflow. So we're gonna see what happens. All right, everything is in place now. There's the temperature sensor for the top element. As you can see, it's just chilling over there. As you can see, there it is. So this guy basically right there, this is our temperature sensor. It's just chilling there. This is the chip that we're gonna reflow, and basically, yeah, we're gonna see what happens with the reflow process, and that connects to the back of the machine. We're gonna go ahead and start the program. I'm gonna check, we have the fan, the cooling mode's good, that's alright. And then yeah, we want the bottom elements on. Actually, you know what, because this is only gonna be part of it, we're gonna increase this to about, actually 160 is alright, because this gets a bit higher, so we're gonna leave it at 160. I'm just checking to make sure there's nothing else that we're missing. Yeah, I'm gonna just double check a couple things, and when I hit the start button, I'm gonna go ahead and start filming, and you guys will see all the magic that's happening. So we're about to go ahead and hit the start button because everything is ready, and we're gonna look at what happens here. So we're gonna go ahead and actually, before I go ahead and do that, let me check one more thing. and that's gonna be let's see, what is it here? Yeah, here. All right, here we go. So we want only, I would only want these two heaters to be on. So only these two heaters should be on. So that means this guy, we turn him off. There's two switches here on the side actually that control whether or not some of the heaters are on or off. So this one I want off, that one I want on. Basically only the two inner ones. Yeah, so he's off. This is on. All right, so we're ready to go. Let me go ahead and let me start the run. All right, so now we're running, and I have to want to turn the fan on because I almost forgot that. So here we go. This is the bottom element, so the bottom two elements, and this is the top element. So he's heating up pretty fast. We're gonna watch and see what happens. Actually, you know what? We'll let it run and we'll see what happens. So I believe we actually just completed the cycle. Yeah, because it stopped. Now we're going down. Everything is cooling down. So there's the graph, basically going up and up and up, and now we're just going. Now it's going down. It's going down. There's the chip. You can see some of the smoke already coming off. Everything seems to be in place. Nothing exploded, which is a very good sign. So hopefully that did the trick, and we should have a working receiver now when everything we put it back together. So yeah, so we're gonna let it cool down, and actually I should turn on the cooling fan right here because now it's done. So we're gonna let the fan run a bit, and yeah, so we're good to go, and let it cool down because everything is still quite hot. So we're gonna let it do its thing, and we'll come back to you when it's on. Here is the board out of the machine. Cleaned it up a bit with some isopropyl alcohol. Maybe if you can see, I don't know, the balls look very nice. Everything is nice and even. There's no missing components, nothing flew off the board, nothing burned. That's still intact from before. And even the underside where that was reflowed, this looks actually really, I'm very impressed with the outcome. Nothing missing on the board whatsoever. Nothing missing. So we're gonna go throw it back in, and we're gonna give it a shot, and we're gonna see. Hopefully that solved the problem, and we'll take it from there. Everything is back in. It's all wired up. Isolation transformer is on. We're gonna go ahead, give it a first power on, and we're gonna see what happens. So that's a good sign. Everything is showing up. Look here. I would say that's a success. So here we have our inputs. Sorry, not inputs, but our surround sound setup configuration. And the fact that that's lighting up is a very good sign. So I'm going to go ahead and at this point, actually, I'm going to hook up some speakers. And we're going to make sure that everything is working in the back. So before I ring up the customer, tell them the good news and give them back the unit, I'm going to just, again, this is a very good sign. So I'm very happy how that came about. Yeah, we're going to hook up some speakers, put some music, and we'll see what happens. All right, so we are back, and I just spent maybe about half an hour now so far playing some music, and we have our video output. This is from the HDMI on the back of the board, so that's a good sign. And if you look very closely, all the speaker, well, two of them, because I have it set to stereo, this is now enabled. Everything is working like it should. Music is coming out. I'm not playing any music right now because I just wanted to film this segment. So everything is back to normal, everything is working, and I would call this a success. Uh, my words are fumbling around as usual. So that's pretty much it for this repair, really. So we had a couple of bad caps on this auxiliary board, if you want to call it, and we had the DSP chip that needed to be reflowed because that had maybe a couple bad connections under it. So we got that all sorted out, and I also went ahead and I checked these over here, and these are all testing okay, so there's no problem on this board. Usually really it's where the DSP chip is, that seems to be where all the problems start with. So but yeah, so that's all said and done, that's fixed, and I'm gonna call the customer, I'm gonna contact him, and I'm gonna tell him that it's ready to be picked up. So, and also maybe just if you want to see this, there's the screen. If I launch there's a service menu here. Yeah, there you go. So everything is working like it should. It's good. It's back in order. And if I hit this button, I believe, yeah, here you go. So I'm not gonna mess with the settings too much because it's just I don't need to. So we're gonna leave it at that, and yeah, everything is working. This HDMI is working, so I'll be very surprised if this customer is gonna have any more problems with it. So I'm gonna let him know the good news, and he can come pick it up, and he will be on his way. So if you guys like this video, please leave a thumbs up, put down a comment down in the bleep boop section if you want to, and make sure you subscribe to the channel and hit the bell so that you don't miss a new video when I upload it, and to keep in track and in the loop with this kind of stuff if this is your kind of thing and you liked. So until next time, take care, guys. Bye-bye.